This is the source code for my cloud post system. It is a post detection RESTful web service built using Fast API. In this main Python, I define a Fast API app and the class code imaging request, which specify the exact format of the incoming JSON request. Each request must contain an ID and a base64 encode imaging. This makes the exact JSON segment described in this assignment. This function here, post information, handles the API post information post request. It receives a base64 imaging, decodes it, and passes the imaging to a detection function called detect post, which runs inference using the YOLO v11 post model. Then the server returns a JSON response containing a list of key point, XY probability, a list of bounding boxes, the imaging ID, and the time taken for pre-processing and post-processing. There is also a second endpoint API post information annotation, which returns the annotated imaging in base64 format for visualization. Now I will show you my Docker file, which I use to containerize my Cloud Post web service. I start with the base imaging Python 3.9 sling to keep it lightweight and compatible with the Fast API framework. Then I copy all source code files into the app directory inside the container. Finally, I set the container to run UV format app on port 60001 when it starts. This allows Kubernetes or Docker to serve the web service automatically on launch. This Docker container fully packages the model code and environment so it can be deployed anywhere consistently, including in my Kubernetes cluster. I install Docker using apt install docker.io and Kubernetes using apt install kuberlate and kubectl. As shown, I'm using Docker version 28.1.1 and Kubernetes version 1.32.3 and Ubuntu 22.04. For networking, I'm choosing Funnel because it's lightweight and easy to configure for small cluster. Here is my current cluster with one control plane and two worker nodes. The internal IPS control nodes are in the same VCN Kubernetes cluster. Info shows the API server is running on the master node. This is my deployment YAML. I define a deployment named Cloud Post deploying with 4 replay cards. It's running one container from my imaging Vito 14565 Cloud Post service latest. I also set CPU and memory limits to avoid overloading the nodes. The container listens on port 60001 and runs Unicorn to service the Fast API app. This is a service YAML. It explores the deploying with a node port type, mapping internal port 60001 to external port 30001. This makes the service accessible from outside using the VN's public IP. I build the Docker imaging locally using the command docker build, then push into Docker Hub. In my deployment, Kubernetes posts the imaging using Vito Y4565 Cloud Post service latest. These are my 3 OCI virtual machine, 1 master and 2 workers. I also show my Monash username for verification. The public IP of the master is used for internal access to the node port service. In my security list, I open TCP port 3001 to allow internal HTTP ports requires to reach the Kubernetes server. I also configure routing and internet gateway to allow outbound imaging polling. This is all my security list. My deployment is running for port as expect, and my node port service is listening on port 3001. I can send base64 encode imaging from my local machine to the Fast API service and get a node result. Finally, to demonstrate load balancing, I check the logs of all 4 parts in our deployment. As you can see, each part has received at least one post estimation request. This confirms that Kubernetes is correctly distributing the incoming HTTP requests evenly across all parts in the cluster. In this part, I will introduce our load testing script. Locals Python is user locals framework to simulate user sending post requests to our API. The class post estimation user represents a virtual user. When the test starts, each user randomly selects an imaging from a local folder, encodes it base64 and send into the API post estimation endpoint. The payload follows the required format with ID and imaging, and the request is sent using self.client.post with JSON headers. Now I will run locus using this command to expose the test interface. The service is hosted at port 30001, and we expose the locus web UI at port 8089. In the UI, I enter the number of simulate user and their spawn rate. Once start, we can monitor the performance of our API. As you can see, the dashboard shows requests per second, average response time, and failure rate. This helps us verify the currency handling of our Kubernetes service. That concludes my demonstration of the Cloud Post system. I'm showing how the web service was developed containerized with Docker, deployed using Kubernetes, and successfully tested with Locus. Thanks for your watching.